Hello and Assalamualaikum. My name is Nabila Husna Binti Zulkafli. Today I am going to do a thesis presentation about my topic, a review on the impact of microplastic on the feeding mechanism of oyster for my final year project. So for the introduction, Magellana species is filter feeding organism that can easily found in sheltered water or estuaries area, especially in the intertidal and shallow subtidal zones to a depth of about 3 meters. Magellana species has a wide elongated shell with an average size of 150 till 200 millimeters. The two valves are solid but unequal in size and shape. The left valve is slightly convex and the right valve is quite deep and cut. Oysters are commercially important species and ecosystem engineers, and they can provide ecosystem services including water filtration and shoreline stabilization. The large-scale use of plastic products and poor management by consumers have resulted in 10% of plastics ending up in oceans. It is estimated that approximately 5.35 trillion plastic particles float on the surface of oceans and seas. Microplastic is particles that less than 5 mm in size and can easily be ingested by the filter feeder organisms such as oyster. For the marine filter feeder organism, the suitable salinity is very important because salinity is considered one of the most consequential environmental stressors for marine bivalve. My problem statements are: oyster is filter feeder organisms, so they will filter all the particles in water they live in, including the microplastic particles. Then, the ingestion of microplastic particles will affect their feeding mechanism, especially their ingestion rate. Different range of salinity can affect the filtration rate of the oyster. The digestive system will be disturbed and the oyster will lack of nutrient. So my objectives are to determine the impact of different concentration of microplastic on oyster through their filtration rate. The second one is to determine the impact of microplastic in different range of salinity on feeding mechanism of oyster. The methodology that I use is literature search, study selection, data organization and reporting. For the literature search, there are 3 steps that are involved, which are search. Step 1, I search the article about this topic from Elsevier, ResearchGate, Springer Link, Google Scholar and Science Direct. Step 2, I use the keywords that are related to the topic such as oyster, microplastics, filtration rate, salinity and feeding mechanism. Step 3, the collected articles then exported to the Mendeley desktop in order to remove any duplicate articles. So for the studies selection, article has been chosen by screening the title, abstract, obtain full text article from the databases search. All the duplicates article then has been filtered out by using the laptop software Mendeley Desktop. Some of the articles were rejected depends on the exclusion and the inclusion criteria. For the data organization and reporting, the data that has been seized from each study were arranged based on the keyword used for this review, which are oyster, microplastics, filtration rate and salinity. So for the result section, there are 3 research findings that I want to highlight. The first highlight is modes of experiment used by researchers. The second highlight is filtration rate of oyster in different concentration of microplastic. And the third highlight is filtration rate of oyster in microplastic waters at different range of salinity. So the modes of experiment used by researchers are: first is laboratory-based experiment, mesocosm, or the other one is field-based experiment. There are 14 published articles involved in this report. 12 published articles conducted laboratory-based experiment, mesocosm, while 2 published articles conducted the field-based experiment. So based on the second highlight, filtration rate of oyster in different concentration of microplastic, based on the graph, it shows that the lowest filtration rate happened when the highest concentration of microplastic presented in the waters that the oyster live in it. It also shows that the existence of microplastic even in low concentration in waters can affect the filtration rate of the oyster to become a little bit slower rather than filtration rate of oyster in the waters with no microplastic. So for the third highlight, so based on the graph, the lowest filtration rate of the oyster detected when there were microplastic presence in water with salinity 45 ppt. The graph also shows that the filtration rate of oyster was a little bit higher in waters that contain microplastic with 35 ppt of salinity among the presence of microplastic with the other salinity treatment. The highest filtration rate of oyster recorded when there is no presence of microplastics with normal salinity of waters that encourage the oyster to filter better. The concentration of microplastic used for this treatment was 2 until 8 microgram per liter for all 3 treatments. The findings for filtration rate of oyster in different concentration of microplastic is microplastic can have direct adverse effect on bivalve by impairing their filtration activity. Microplastics are delivered to the mouth from labial pulps and reach the digestive tract, which then allows the accumulation of microplastic in digestive system. However, higher concentration of microplastics in the water then contributed to higher amount of microplastic accumulated in hepatopancreas cells and show potential for bioreactivity and sublateral impacts, especially on the filtration rate. The exposure of the oyster to the low or higher doses of microplastic can affect the filtration ability to decrease, bisal threads and attachment strength impaired, hemolymph proteome change. The reduction in filtration activity will reduce food uptake and could thus decrease the energy allocated to growth and the other essential life functions. The findings are the lowest filtration rates were reported in microplastics waters at 45 ppt, as these were extreme salinity values as n additional factors and there were microplastics presented in their waters. However, the filtration rate is a bit higher in microplastic waters at 15 ppt rather than 45 ppt. This finding indicated that tolerance of oyster to low salinities was wider than that to high salinities. This may be attributed to the physiological performance of oyster at lower salinities as they exhibited partial or complete contraction of adductor muscles and a slowing or cessation of water current through the gills as suggested by Newell. The results also shows that it could be contributed by a mechanism to tolerate salinity where bivalves close their valve to isolate themselves from the external environment and osmolarity differences, which then lessening the filtration. As a result, normal physiological processes are inhibited. In order to study the research about microplastic, most of the researchers prefer to conduct the laboratory-based experiment mesocosm rather than field-based experiment. This is because the mesocosms is very useful for assessing the stresses. Besides, it allows replication and statistical evaluation, while the field-based experiments are difficult to replicate or to find reference systems. Microplastics not only directly affect the filtration activity, assimilation efficiency, feeding behavior, growth performance, and fecundity of bivalve, but also indirectly affect bivalve by changing the structure of their sedimentary habitats, delivering toxic substances and impairing their food resources. Microplastics are commonly detected in commercial edible bivalve, including mussels, oysters, and clams. The consumption of contaminated bivalve is a main path of exposure for the intake of microplastic, which may pose potential human health risks. The management of microplastic should be improved in terms of bivalve fisheries and food safety. So this is all the references that I use throughout my review. So that's all from me. Thank you.